Hi and welcome to an introduction to Centeo's scoring sheet for the TG40. The TG40 has 5 temperature zones and it's generally used for screening and the optimization of protein crystallization. Now, it can be used to gather an awful lot of data, but what we're trying to achieve in this scoring sheet is actually streamlining the analysis of that data. And I'll explain what I mean by that. So what we have is we have 7 sheets within this workbook. We have a scoring sheet, an analysis sheet, and then some graphs. And so what the intention is when you go to your TG40, when you first turn on the unit, we're expecting you to score what's going on. So I have a picture here, and this is sort of embedded in the file of the TG40. So we have wells A1 and well B1 and well C1 and well D1 and E1. So we have actually 5 temperature zones on the TG40. We have temperature zone 1 here, temperature zone 2 here, temperature zone 3 here, temperature zone 4 here, and temperature zone 5 here. So when you open up this this spreadsheet, our intention is you'll be using your TG40, and I have a TG40 running on this PC, so I'm just going to drag in the window. And so what the intention is you'll read off the temperatures, you'll look under the microscope at what's happening in the wells, and you'll score them. And you'll do that at sort of T is equal to 0 hours, maybe T is equal to 24 hours, maybe T is equal to 48 hours, maybe 72 hours. And we've designed a spreadsheet to really kind of speed up all that analysis. So, just so we're clear, the boxes on the scoring sheet that are highlighted in yellow are editable, and so in well A1 you'll know what you have in A1. For example, it could be kind of protein 1. And when you do that, that change will propagate through the spreadsheet. So when you go to your analysis sheet, that name will appear there, and it will appear in the graphs later on. So if you make changes to the yellow boxes, it will propagate throughout the sheet. So if we look at this kind of first grid area, the editable regions are: what's the time at which you're doing this analysis, what's the temperature of the row, so what's the temperature of row 1. And now I'll just bring on my example at the moment. So at the moment my row 1 is at 8 degrees C, so I'll make my row 1 8 degrees C. My row 2 was at 12 degrees C. My row 3 is at 16, my row 4 is at 20, and my row 5 is at 24, so I'll do that. Okay, so at T is equal to 0, so when I first start this experiment, the first row is at 8 degrees C, and I've done that. The second row was at 12 degrees C, and I've made that change. The third row is at 16 degrees C, and I've made that change. The fourth row is at 20 degrees C, and I've made that change. And the fifth row is at 24 degrees C, and I've made that change. Now, the next thing to do is actually look under the microscope and see what actually is in those wells. And if you are not sure how to illuminate the TG40 under the microscope, then just click this link here and there'll be an explanation on how to do that. So I'll assume that, and I'm just going to zoom in so you can see this more clearly. So we have clear drop, phase separation, regular granular precipitate, bifringent precipitate, spherulites, needles 1D, plates 2D, X-tals smaller than 0.2 millimeters, X-tals bigger than 0.2 millimeters. And so you have to choose what you're actually seeing in that well at that time. I'm just going to zoom out again. Right, so I'm going to assume that everything is clear when I first started this experiment. Now this actual plate has been running for, as I can see here, 15 hours, 45 minutes and 40 seconds. Alright, so what I'm going to do now is I'm going to assume that I've returned to the plate 15, I'll make that 16 hours later. Again, that change will actually propagate throughout the sheet. So let's say I return to it, and I'm now going to go systematically score all these wells. Again, if you're not sure how to illuminate, click this icon, it'll tell you how to do that. So I'll score, effectively this well here, and I'll assume that it's not doing anything. Maybe this well here, phase separation. I'm going to kind of make this row pretty mediocre in terms of maybe clear drop, phase separation, maybe some precipitation, things that are not that spectacular. Maybe I will have a slightly better one here. Clear drop. And I'll also just check the temperature. So the temperature on row 1 is 8, 12, 16, 20 and 24. So I'll get those correct. 8, 12, 16, 20, 24. Alright, cool. So as I say, anything in yellow is an editable region. So far we've sort of discussed that you can edit what's actually in those wells. You can though these are brown, all these brown areas are actually drop-down menus that allow you to actually score what's in the well. Time's important to us, and temperature's important to us. So when I actually go to my analysis sheet now, so I have a score sheet where I actually enter the data, and then an analysis sheet, and the times are all brought from the score sheet. And what we have going on here is when we first started, I said that they were all clear, and that's translated here. And then one of them actually did a little bit better. I sort of scored it higher. And the reason that is orange is because I have a kind of level here. This is the analysis sheet. And what we're doing is we're quickly letting you eyeball, did I get anything that was vaguely successful? So, let's say I kind of thought that phase separation was vaguely successful. Suddenly some of the boxes change color. Green, because they're basically scoring above phase separation. So whatever in the list is above phase separation is green. If I just have phase separation, it's orange. And if it's just clear because it's less than phase separation, that's clear drop, then it remains red. So you can kind of see that it quickly allows you to eyeball. And let's just pretend I carried on doing my my experiment. So I said that we had 0 hours, 16 hours. Let's say I came back 24 hours later. So I'll make that 40. All right. Now let's say that I was actually going to start seeing something more interesting. So I'll start scoring these. And I'll score one of them a little bit higher. This is kind of nice because you can kind of automate your scoring process. By that I just mean just go in the lab, quickly do it, and then this piece of sort of software will just allow you to quickly come back and analyze it. So then when we come back to the analysis, this new row has responded to those new scores, and you can sort of quickly get an eyeball that with time, you start off with clear solutions. At 16 hours, things start looking a bit healthier. You start getting some oranges and some greens, and then after 40 hours, it went sort of green again. So this is a quick eyeball, and what's happening all the time is we have some thumbnails over here that tell us the score. It's got a few sort of parameters going on. It's got the score in here, and it's got the temperature on this axis, so we can kind of see scores were going up because I've completed the data for 40 hours. I'll complete the data for 120 hours in a minute, and we'll see how the graph changes. I'm also just going to make sure I get these temperatures correct, because again, all these are not editable regions. They come from the score sheet. So let me just do a few temperatures as well. So that's still at 8 degrees C. So the sheet has responded to that now. It's put the 8 degrees in there. Now let's just sort of complete this experiment, and let's just say at 120 hours, you know, again, that's an editable region, but let's assume I came back after 120 hours. I'll score it. Sorry, not I'll score it, I'll put the temperature in. And now I'll score it. It'd be nice if you got all this, but let's see. So I'm going to score them all pretty high, because then I'll show you how we can kind of quickly eyeball then and see which are the most successful. Alright, so the graph now shows in row 1, that was the temperature through the experiment, so you can see that we can sort of see that it was a constant temperature. We do have some other tabs down here. These are like the zoomed in views, so these are kind of effectively thumbnails of what was happening. You can get a much sort of high resolution image of what was happening here. You can see the temperature was kind of constant. You can see how the scores were generally going up with time. And what I'm going to do here is, let's just say you only were interested in wells that had sort of, you know, 2D crystals. We can quickly do that, and you can just very quickly see, you know, you didn't have to go around looking. You just shines it out. You can nice and quick, nice and easily. So right, in summary, what do we have? So we have a score sheet, which you can have running on a PC, sort of, you know, in the local area. You can say what's in the wells. These names will all, whatever you enter into these boxes, translates or propagates throughout the spreadsheet. You enter temperature. You can enter the time. These propagate to the analysis sheet. You get a thumbnail graph of what's going on, and then you have effectively the TG40's matrix, which is color-coded relative to this filter. So if I drop this down to clear drop, just about everything became good, because, you know, but if actually then I start being more stringent in what I'm interested in, then most things are red and the greens. And then just so for your analysis, then there's also these zoomed in views as well. So if you want to sort of if you get stuck, come to the video online. This comes to the Centeo website. If you're not unsure about how to illuminate the TG40 under a microscope, click this, and we also always look forward to your feedback as well regarding the TG40 and Centeo. So thank you very much. Take care.